Welcome back to my channel. I am student of Sri Venkateshwara College of Engineering. My name is A. Purna Seshian, Department of Information Science and Engineering, USN 1VE 22IS001. Today, the main topic of our presentation is Module 3 of Data Structures. Subject code is BCS 304. Let us see what exactly we are going to learn in Module 3. So, first we are going to learn about additional list operations, and next sparse matrices, and finally doubly linked list. Let us see what are additional list operations. Additional list operations are: first one, traversing, to traverse all nodes one by one, and then insertion, to insert new node at specific positions, and deletion, to delete nodes from specific position. Insertion and deletion can be done at beginning and at specific location and also at the ending. And finally searching, to search for an element from the linked list. So let us see the program segment for each one by one. So the below diagram is a linked list representation. Let us see the traversing programming segment. So start node asterisk temp equal to start. This denotes we are pointing to the starting of the node. And next, while temp not equal to null. So this shows until we reach the last node, it starts traversing each and every node one by one. So the loop will not start until we reach the last node. Now print temp arrow operator data. Arrow operator is nothing but referencing operator in linked list. And temp equal to temp arrow next. After printing the data, it points to the next node. So this is how traversing works. Now let us see the program segment for insertion. Now we are going to see program segment for insertion at the beginning. Insertion, if you know insertion at the beginning, even insertion at the specific location and even insertion at the ending will also be similar. Struct node asterisk new node. So we have created a new pointer that is called new node. Now new node equal to malloc size of struct node. So we are dynamically allocating the data with the help of malloc, which is inbuilt function provided by standard library in C. Now new node arrow data equal to 40. So we are storing the data 40 in new node. And new node arrow operator next equal to start. We are pointing the new node at the start of the node. So this shows our new node is inserted at the beginning. Start equal to new node. This shows our new node is at the starting. Now let us see deletion. Deletion at the beginning is so simple. Start equal to start arrow operator next. This shows now start is pointing to the next node. So the previous node is deleted. Now let us see finally searching. So boolean search of struct node asterisk head comma int x. So here we are going to find whether int x, that's nothing but some data, is present in the head pointer or not, or is present in the linked list or not. If it is present, it will provide true, else false. This is a simple single list program to perform additional list operations such as traversing, insertion at beginning, insertion at ending, deletion at beginning, deletion at ending, with student data with the fields name, USN, branch, and phone number. We are creating a structure to make sure different types are used. Name, USN, branch are of char data type, some phone number are of integer data type, and it also has a link pointer variable. First is the pointer variable that points to the first node in the linked list. So this is a structure with student info, and we are going to create a menu that is so that we can perform a selection statement, that is switch case. This is a switch case with case 1 to 7. If user enters between 1 to 7, the respective function will be performed. If he enters other than 1 to 7, it will show invalid choice. Now let us create a node which is dynamically allocated using malloc. Void get node x equal to node malloc size of struct node x arrow link equal to null. So we have dynamically allocated memory to the node. And now let us read the student details using readof method. So temp equal to get node of, then a printf, enter usn ampersand s modulus s temp arrow usn, enter name modulus s temp arrow name, enter branch temp arrow branch, enter semester, enter phone number. And now we are going to create a single linked list. In order to create a single linked list of student details, we need to know the limit of how many students need to be added. So that's why we are going to give printf enter the number of students, scanf modulus the ampersand 10, and we are going to run the loop for n students, and printf enter the details of student I, read of This will redirect to the called method read function, and we can and the student details are read. And if first double equal to null, so if the first points to null, then make temp as first node, else temp arrow link equal to first, and to first equal to temp, so that we are making new node as the first node. So therefore, we have successfully created the singly linked list with the n student details. Now let us display each student details and the count of nodes in a linked list. Void display count. Int count equals 0, first equal to temp. If first double equal to null. So if a first double equal to null initially, that shows that the list is empty. Else print the student details while temp not equal to null. So we are going to run the loop for until we reach the null. So we are going to traverse each and every node and print the respective student data. And now insertion at the beginning. If first double equal to null, first equal to temp. Else temp arrow link equal to first equal to temp. So we have successfully added a node at the beginning of the linked list. Now let us see insertion at the ending. Void insert n, node last equal to first. So we are making a last node as the first node. If we print the student details, read off. So we are going to read the student details one by one, like name, USN, SEM and phone number. If first double equal to null, shows that if there is only one node, then insertion is very simple, first equal to temp. While the last arrow link not equal to null. Loop to each last node, last equal to last arrow link equal to temp. So we have successfully added a node at the ending of the linked list. Now let us see how to delete a linked list at the beginning and ending. In order to delete a linked list at the beginning, we have to allocate temp equals to first. If first double equal to null, print the list is empty. Else the deleted element will be temp arrow USN. So the USN containing the name and SEM phone number will be deleted. First equal to first arrow link, so that we are pointing to the next node, so the previous node will be deleted using free of temp. Now let us see deletion at the ending. A node last equal to null. So we are making a last node as null such that it shows that it is the ending of the linked list. Temp equal to first. If first double equal to null, it implies the list is empty. Else if first arrow link double equal to null, it means that there is only one node. So it can directly be deleted as temp arrow USN free of first equal to null, so that the list containing one node is deleted. If there are n number of nodes, we have to check using while condition. While temp arrow link not equal to null, last equal to temp equals to temp arrow link, last arrow link equal to null. And we are going to printf for deleted node is modulus s temp arrow USN and free of temp. This we are going to delete the node which is at the last. So we have seen the additional list operations which performs traversing, insertion, deletion at beginning and ending. Let us see is it working right or not. So this is our output which I have shown. Now this is the menu. So if we give choice as 1, it will asks the number of students. So we are giving number of students as 2. Enter the details of student 1. So we are adding the student 1 detail as USN ISC01 and student 2 USN CSC01. So in order to check whether it's added successful or not, let us display the data. So if you give choice as 2, the student details are displayed as the last in first out order in a stack. Now let us insert a node at the beginning. So let us give choice as 3, and it is asking student details. Let us give USN as ME01, and let us display and check. So we can see ME01 is added to top of the stack, and let us insert another node at the ending. So let us give choice as 4, and we are giving USN as CV01. Now if we display, you can see CV01 is not on the top, it's at the bottom. So it successfully we have added USN CV01 at ending of the list. Now in order to delete a list at the front, let us give choice as 5. So it is showing deleted element is ME01, and if we give choice as 6, deleted element is CV01. To check whether it is successfully deleted or not, let us display it. So if we display, we can see only ISC01 and ISC01. So this implies the first node and the last node is successfully deleted. For this we are going to perform additional list operation using singly linked list. Now let us see what is sparse matrix. A sparse matrix is a special case of a matrix in which the number of zero elements is much higher than the number of non-zero elements. As a rule of thumb, if 2 by 3 of the total elements in a matrix are zeros, it can be called a sparse matrix. So it's nothing but when you have a 4 cross 4 matrix, for example, it consists of totally 16 elements. But if you have more number of zeros than non-zero elements, then that matrix is called a sparse matrix. So let us see how sparse matrix exactly looks. So here is a 4 cross 4 matrix where it has to consist 16 elements. But here we are having only 5 non-zero elements and rest all are zero elements. So this is called as a sparse matrix. Now let us see sparse matrix representation. Sparse matrix representations can be done in many ways. Following are two common representations: array representation, linked list representation. Let us see one by one. Method 1, using arrays. 2D array is used to represent a sparse matrix in which there are 3 rows named as row, index of row, where new non-zero element is located. Column, index of column, where non-zero element is located. Value of non-zero element located at index, row, comma, column. So let us see how we are going to represent it. So here is a 4 cross 4 matrix where there are 5 non-zero elements and rest all are 0 elements. So this is a sparse matrix. And now this and the right side is called array representation, where 0 represents the 0th row and 2 represents the column where non-zero element is present, and 3 represents the value in the column 2 and row 0. And next we have 0, 4, 4, where 0 is the first row, that is nothing but 0th row, and 4 is the column where non-zero element is located, and 4 is the value. So this is how array representation looks. Why we are using array representation is that when we have to represent 4 cross 4 matrix, it requires of 16 elements. Each element requires 4 bits, where it consumes lots of memory in the heap. But whereas if we do it in array representation, it can be represented simply with 3 rows and 7 columns. So where the memory representation is utilized efficiently. Now let us see array linked list representation. So this is a linked list representation. In linked list, each node has 4 fields. These 4 fields are defined as row, index of row where non-zero element is located. Column, index of column where non-zero element is located. Value of the non-zero element located at index, row, comma, column. Let us see how exactly it looks. Also, we are going to show the next node, address of the next node, which is common in all linked list representations. So this is how linked list representation looks. Here we have same 4 cross 4 matrix. So now in a linked list there are 4 parts. First part is row of non-zero element, and second part is column of non-zero element, and third part is value of non-zero element, and next we have the address which is pointing to the next node. So this is how linked list representation looks in a singly linked list, and this is not a doubly linked list. In case of doubly linked list, we can see 2 address pointing to previous and 1 to the next node. Now let us see doubly list representation. So first, before showing doubly list representation, let us know what exactly is doubly linked list. A doubly linked list is represented using the linear arrays in memory, where each memory address stores 3 components: data value, the memory address of next element, the memory address of previous element. Before we have seen single linked list, where it has memory address of only the next element. It is not having memory address of previous element. So that if you want to traverse each node, we need to go from starting to the ending. And if you want to insert, we need to go from starting to the ending. If you want to traverse in between, you cannot go to the previous node. You need to come from the beginning. Even if you want to delete an element in the between, we need to go from starting of the node. So it is to overcome this, we are using this doubly linked list. In doubly linked list, we can point even to the previous node. So traversing can be done in 2 ways, insertion also 2 ways, and deletion also 2 ways. So it is more efficient to use doubly linked list. Okay. So this is a programming segment for doubly linked list. Struct node int data, struct node start next, struct node start previous. So we have 2 pointers that is nothing but next and previous, where next points to the address of the next node, previous points to the address of the previous node. So this is a doubly linked diagram where we have a pointer that is nothing but 400, which is the address of the first node, and next we have 600, which is the address of the next node, and next we have 800, address of the next node, where it also shows the previous node addresses, that is nothing but 400 and 600. And the 0 at the beginning and 0 at the ending shows the beginning of the doubly linked list is null, and ending of doubly linked list is pointing to null. So this is all what we have learned in this module. So this is what we are going to learn in this video, that is doubly linked list, sparse matrices, and additional list operations. For more such videos, Please like, share and subscribe to my channel. Thank you.